Assalamu alaikum kids. Inshallah, in this video we will talk about two more quantities, which are volume and density. So let's talk about volume first. Volume of an object is the space occupied by an object. As far as an object is concerned, there are two types of objects in physics. Number one, there are regular objects. The volume of a regular object can be found using fixed formulas. These right here are some examples of the shapes and their formulas that you need to remember. The first one is a cube, and for a cube, the volume is side cubed. The second one is a cuboid. For this, the volume is length into breadth into height. This right here can be said to be the length. This right here is the breadth, and this right here is the height. It doesn't really matter in which order you put them. You can assume that this right here could be the breadth, this right here could be the length, and this right here could be the height, or any other combination is completely fine. It doesn't really matter. 2 times 3 or 3 times 2 doesn't make a difference. The next shape is a cylinder. For a cylinder, the volume is pi r squared h, where r is the radius of either the top face or the bottom face, and the height is the distance in between the two faces. Of course, the height is going to be perpendicular to both the faces as well. Then you have a cone. For a cone, the height is from the top converging point to the base, and the radius is this right here. So this right here would be the radius, this right here is going to be the height. Sometimes a lot of kids make the mistake and they consider the slant height to be the height of the cone, which is wrong. The slant height is L, it's not H. The height of an object or the height of any shape will always be perpendicular to its base. And that's how you can figure out the height. And the formula for cone is 1/3 pi r squared h. So it's essentially 1/3 of the volume of a cylinder. Then you've got a sphere. The volume for a sphere is 4/3 pi r cube, where r is any length in any direction from the center of the sphere. So these right here are certain formulas that you can use to figure out the volume of regular objects. So after having talked about regular objects, we are now going to talk about irregular objects. Now, irregular objects do not have fixed shapes like cubes and prisms. Since there is no definite shape, there are no formulas that can be used to figure out the volume, and the volume can be found using other techniques such as displacement of water. What is displacement of water? When an object is submerged in water, it will cause the water level to rise. This rising of water level is known as water displacement. The steps to measure the volume of an object using displacement of water is as follows. Number one, you measure the initial volume of water in a measuring cylinder. So in this case, we have approximately 30 centimeter cube of water. Then you submerge an irregular object in the measuring cylinder. So when you submerge, we can see that the volume of water has now increased. So we need to measure the rise in the water level. Now the rise can be easily figured out using the final level, which is around 40, minus the initial level, which is around 30 centimeter cube. And that rise in the volume of liquid will be equals to the volume of the irregular object that we just submerged in water. So let's talk about density. Density is the mass per unit volume of an object. The formula for density is mass upon volume, and its SI units are kilograms per meter cube. You'll frequently see the formula or the unit grams per cm cube as well, centimeter cube as well, but that's not an SI unit. The SI unit for density is kilograms per meter cube. So it's also important to remember the density of water, which is 1000 kilograms per meter cube or 1 grams per centimeter cube. Now, again, so this right here, these densities of water, why they are important to remember, because they essentially give us a conversion between the two units of density, kilogram per meter cube and grams per centimeter cube as well. So we can essentially say that 1 gram per centimeter cube is equals to 1000 kilograms per meter cube. All right, so this essentially gives us a conversion factor. If you want to convert from grams per centimeter cube to kilograms per meter cube, all you need to do is multiply by 1000. And if you want to convert backwards into grams per cm cube, all you need to do is divide by 1,000. Now, another important element for which you need to remember the density is mercury. So the density of mercury has the chemical symbol Hg. So that's mercury. All right, now mercury has a density of 13,600 kilograms per meter cube. But let's say, for example, if I want to convert this into grams per cm cube, so grams per centimeter cube, for kilograms to grams per centimeter cube, we need to divide by 1,000. So divide that by 1,000, and this right here should become 13.6 grams per cm cube. Now this seems a little counterintuitive that grams is a smaller unit than kilograms, centimeter is a smaller unit than meters, but the combined kilograms per meter cube is essentially a smaller unit than grams per cm cube, grams per centimeter cube. And that's why from grams per centimeter cube to kilograms per meter cube, we are actually multiplying by 1,000. And that's it for this video, kids. Inshallah, I'll see you in the next one. Bars out.